Hey everyone, welcome to episode 1 of the fascinating mini-series Math 105 Final Exam Review. We're starting off with rounding. We're going to round 69,278 to the nearest hundred. So let's find the hundreds position. We got ones, tens, hundreds. So hundreds is in the 2's in the hundreds position. So we're going to round to this digit. So we look to the digit to the right. It is 5 or greater. So that means we increase 2 to 3, and we get 69,300. Next up, we're going to round a decimal value to the nearest thousandth. So we're going to locate the thousandth position. That is tenths, hundredths, thousandths. That is the 5. So we'll look to the digit to the right. That is not 5 or more, so we do not adjust the 5 digit. We're just going to leave off everything to the right, and we have 4.765. Next up, we're going to work with some exponents. Here we've got in A and B two related, very similar expressions, but with an important difference. In the first one, the base is just the 3. The negative is unaffected by the exponents. What's really happening here is order of operations. We're doing the exponent first, and then multiply by -1. So we get -9 for that one. But here, the base is -3. So here we're doing -3 times -3. The negatives cancel, and we get +9. So that's the difference between those two. Now for part C, we're going to apply this exponent individually to both the numerator and the denominator. So we get -2 to the third power on top, and 7 to the third power on the bottom. Now -2 to the third is -8, so we get -8 over 343. Next up, scientific notation. So we're going to write 2,480,000 in scientific notation. So the decimal point starts to the right of the number, and we're going to see how many decimal places do we have to move in order to make this number between 1 and 10. So in other words, we need that decimal point between 2 and 4. Then we get 2.48, which is between 1 and 10. So we're going to move 1, 2, 3, 4, 5, 6 places. We're moving 6 places to the left. That means the exponent in scientific notation will be a 6. So this will be 2.48 times 10 to the 6th power. Just remember, if we have a large number, the exponent is positive. If we have a very small number, it's negative. So in the next one, we've got a negative exponent, which means this is going to be a very small number, which means we need to move the exponent 4 places to the left. So that's going to give us 3 zeros, all right, moving forward left, 1, 2, 3, 4. So that gives us 0.0003967. Order of operations. So we're given the values of the variables. We're going to plug them in and evaluate. Y is -3, so we're going to do y squared here. So that's -3 in parentheses squared. Make sure you put it in parentheses because we want to square the entire value of y, not just the 3. So we want to write it like this, not like part A. Minus x is 2, y is -3, and z is 5. Order of operations, we're going to do the exponent next. So that's 9 minus 2 times -3 times 5. Now we'll multiply all these out. All right, 3 times 5 is 15, times 2 is 30, and it's negative. Now we have 2 negatives, so we should keep 2 negatives. A lot of times students will lose one of those negatives along the way. Keep them both. Now we're subtracting -30, that's the same as adding 30. So the answer for that one is 39. All right, number 7. Got a fraction in this one, so we're going to do x times y first, so that is 2 times -3, plus y times z, so negative 3 times 5, all over xy, which is 2 times negative 3. All right, now we can do all the multiplications. We got negative 6 here, plus negative 15 over negative 6. All right, now we can do the addition on top. So that gives us negative 21 over negative 6. Now those negatives are going to cancel, and we can also simplify this fraction. Feel free to do that in your calculator. Or you can divide both the top and bottom by 3, and that gives us 7 over 2. All right, next step, number 8. We're going to simplify these expressions. When we simplify, we want to get rid of all parentheses and combine like terms. So let's get rid of these parentheses by distributing. And now we can combine the like terms. We've got 12x and 6x, that's 18x, negative 3 plus 18 plus 15. 18x plus 15. All right, next up, we got number 9. Now with this one, we're distributing in negative values. And that is the effect of changing the sign of everything inside the parentheses. So this 5, it's positive, this is going to turn negative, so negative 4 times 5 is negative 20, and this negative will turn positive. Make sure you do that with every term inside the parentheses. Change those signs. Minus 3x plus 8. Same deal over here. Negative to positive, or positive to negative, negative to positive. All right, now we'll combine like terms. 8x minus 3x is 5x. And negative 20 plus 8 is negative 12. So 5x minus 12. Now we're going to determine if a number is a solution to an equation. So we're going to check 3 to see if it's the solution to this equation. So that means we'll take 3, plug it in for every instance of x. And now we use order of operations to evaluate. So the exponents first, we got 3 to the third is 27. And inside the parentheses, on this side of the equation, do over here, and that gives us 2 squared. You can do each side of the equation separately in terms of order of operations. So starting with exponents here and parentheses here. All right, now we've got another exponent here, so we'll do that one next. And over on this side, we can do the multiplication. So 15 minus 27 equals negative 3 times 4. Subtracting here, we get negative 12, and negative 3 times 4 is negative 12. Now we get a true statement at the end. The two sides are equal. So that means, yes, 3 is a solution to that equation. Now we're going to solve some linear equations. This is number 11. One of the mistakes I see with these is people trying to add or subtract from both sides of the equation right off the bat. That usually often leads to mistakes. So let's, instead of doing that, let's simplify on the left side first. We're going to combine like terms here. 12x plus negative 3x is 9x. And negative 7 minus 15 is negative 8. So 9x minus 8 on that side, 5x plus 12 on the other side. All right, now we have fully simplified expressions on both sides. Now we can start adding and subtracting from both sides. We got 4x equals 20 divided by 4, and x equals 5. Now when you're taking the exam, make sure you take that value, plug it back in, make sure both sides are equal. Number 12. In this case, we're going to have to distribute to be able to simplify. So we got 6x minus 15 plus 4, and on the other side, 12x minus 4 plus 5. We can combine like terms here, so that's 6x minus 11 equals 12x plus 1. Subtract 6x from both sides, that'll get all the x's to the right. Get rid of that 1 there, move that to the left. Now we got negative 12 equals 6x. Divide both sides by 6 and you get x equals negative 2. Next problem type is solving literal equations. These are equations with more than one variable. For 13, we're going to do x equals y over z. And we're going to solve this for z. That means getting z by itself on one side of the equation. Well, in this case, we got z in the denominator, which is usually much more difficult to solve for. But there's a great trick we can use, the switch trick. We'll just switch x and z and get z equals y over x. And we are done. Now, if you want to know why this works, it requires two operations. It means multiplying both sides by z and then dividing both sides by x. So I'm just doing these both at the same time. The z's cancel over here, the x's cancel over here, and we get z equals y over x. So that little trick combines two operations at once. Nice time saver. Next up, number 14. We're going to solve for y. We got 2x plus 3y equals 15. So we want to get y by itself. When solving, always start with addition, subtraction. So let's get rid of the 2x on each side. Alright, so 15 minus 2x then on the right. Now we're one step away. We still have this coefficient we need to get rid of to get y by itself. So let's divide that out. It's going to cancel over here, and we get y equals 15 minus 2x over 3. Now we're going to solve some linear inequalities and graph the solutions. But for number 15, 3 times x plus 2 greater than equal to 5x plus 12. All right, we're going to solve this now. Start by distributing. Let's keep the x term positive by subtracting the smaller one. That will prevent us from having to remember to flip the direction on the inequality. So that gets the x's to the right, so I'm going to move the numbers to the left, get -6 on the left, and 2x on the right. I'll divide by 2. Notice now we can now divide by a positive number, so we don't have to switch the direction on the inequality. And we get x is less than -3. Let's switch that around. You can write it either way, -3 greater than or equal to x, or x less than or equal to -3. Now to graph this thing, well, we need to mark the boundary point there. We're doing less than or equal to -3, so we're going all the way to the left, and it's less than or equal to, so we use a bracket as the symbol there. So there's the graph. Number 16. Distributing. Now, I think I'm just going to go ahead and subtract 18 from both sides. Right, this stays negative, so we got -3x less than -30. Divide by -3. And now this time we will have to change the direction. Maybe x is greater than 10. Oh, wait, hold on, what did I do? I think, yep, knew I made a mistake there. And it's 6, not 3. There we go. Okay. So now I'm dividing by 6 and I get 5. Okay, x is greater than 5 now. Line this up, we have a 5 here. Now we have strictly greater than, so that is a parenthesis, and we're going to the right. Next problem type, we're going to solve proportions. So we're going to read a description of a situation, set up a proportion, and then solve it. Make sure when you set these up, we include units. So we're starting with a photo, 8 inches tall and 6 inches wide. And we're going to enlarge that photo to be 12 inches tall. All right, so the original photo, 8 inches tall, we're getting 17 over 6 inches wide. All right, there's the original. Relationship between how tall it is and how wide it is, all in one rate. And on the other side, the photo enlarged to 12 inches tall, so we have 12 inches tall over here, and W inches wide on the bottom. So we're going to solve for W. Solve these by cross-multiplying. So we got 8 times W. Don't need to write the units now, we'll just get in the way when we're solving, and then 6 times 12. That makes 8W 72 divided by 8, and we get W equals 9. So that makes the width of the enlarged photo 9 inches. Number 18. 5 packages of turnips can be purchased for $2. How much would 12 packages be? $2. All right, there's our rate, 5 packages for $2. And on the other side, we're getting 12 packages over D dollars. Cross multiply, we got 5 times D and 12 times 2. Notice when I set these up, got dollars on the bottom, packages on the top in both of these. Got width on the bottom, tall, height, I guess, on the top. So make sure you set these up so they're consistent. So we got 5D is 24 divided by 5, and that will make D 4.8. So that makes 12 packages. Cost $4.80. Now problem type 11, we're going to do variation. Starting off with number 19. It says y varies directly with x. So we know that the equation for that is y equals kx, with k being the constant of variation. All right, now y is 96 when x is 16. So we can plug these values in. Get 96 equals k times 16. And we'll solve for k. That will give us the constant of variation. So k is 6. Now I'm going to take the 6 and plug it back in here, and that gives us the equation of variation. So y equals 6x. So there's our equation. And that's the equation that relates x and y together. Now we're going to find the value of x when y is 108. So plug in 108 for y. All right, so plug in 108, solve for x, and we get x equals 18. So there's going to be 2 answers to these, the equation of variation and final answer. Number 20. Now this one, y varies inversely with the square of x. So inversely means our variable's on the bottom. So y equals, k is on top, and it's the square of x. So x squared on the bottom. And we're given that y equals 2 when x equals 4. So 2 equals k over 4 squared, which is k over 16. All right, now we'll multiply both sides by 16 and get k equals 32. And that makes our equation y equals 32 over x squared. So there's the first part of the answer, the equation that relates x and y. And now we want to know what's the value of y when x equals 2. So plug it in 2 for x. This is 32 over 4, which is 8. So y equals 8. So that's the end of part 1. Stay tuned for part 2.